Dear students, myself Vikas Sharma, and here we are starting with a new topic, which is Euler's method. This method is very important for the syllabus wise as well as for the topic of differential equation. We are here given some methods to solve the differential equations. The method is separation method. Second one is the homogeneous method. Third one is integrating factor method. But many of the equations are there, and I am just going with the first order differential equations. Many of the equations are there which are not being solved with these three methods. Then we have to further move with some another method. Now here the method is Euler's method. The first thing is, I just want to explain you what is the Euler method and what is the geometrical interpretation of this Euler's method. What we understand with it. But the first thing I want to explain you that this gives a approximate value. It won't give you the exact value. Mind it. Okay? Just wait. The first thing is, what is the geometrical meaning of Euler's method? Okay, before doing the numericals, before doing the questions, I just want to go with this thing. Let there is a differential equation in first order and it may be in the form of fxy. Okay, this is the differential order of first differential equation of first order. Sorry. And we know that y x naught is equals to y naught. Okay, the first point is x naught, y naught is the first value. Okay, now what is the meaning of all those things? Let's go with the help of a graph. If you go with the graph and if I draw it like this is the graph. And if I draw a structure like this. Now in this graph, let there is a point and this point be x naught, y naught. And let we have to find out the value for yn when the value of x is xn. Okay, this is xn. Clear? Now here this is x naught. Okay, we have to find out the value of yn at xn. Now here this is a point xn y. Clear? Now the next thing comes here is, what is the value of n? Therefore there comes h, which is said to be the step size. What is this? The step size. And step size is equals to b minus a over n. Okay, where a is x naught and b is xn, and we have to divide this by n. N is the number of steps which we are taking in. Now the one thing you must know that you are having the approximate values with the help of Euler method, but the approximate value will be much closer to the exact value when n is more. More the n is, more accuracy the value of yn will be. Okay. Here in this case, if you are having x naught, y naught, and here this is x and y. Okay. Now just try to start. Now here we are having x naught. Here this is, at this point is x1. There is another point, and here this is x2. Okay. Now here this is xn and x naught, x1 and x2. Now in these two cases, in these three cases, if I go with x naught, y naught, and the first thing is, if I want to find out the value of the slope of f xy at the point x naught, y naught. Okay. If I have to find out the slope of slope at x naught y naught, it will be how much? We know with the help of that the slope is equals to d by over dx at the point x naught y naught. What it means? It means if f x naught y naught. Okay. Now here in this case, if I draw the tangent at this point and let this tangent be like this. Okay, this is the tangent like this. Clear? This is a tangent at this point and this point is x naught y naught. Okay, fine. You are saying that everything is fine. Okay. Now I am just going with this part only. I am just only this part, and I will draw this part in the next space. In the next space, I will draw this, and here let us wait. Now I am going with this part, and this is the part here which I am taking. It's going somewhat light. Now the graph is, let's take the graph like this. Okay, and now here this point is x naught, and here this point is x naught y naught. Okay, somewhere this point is x1, and somewhere this point is x2. Okay, the step size must be equal. Here this is h, and this is h. Okay, this part will be equal. Now if I draw the graph for this part, it will go like this. Okay, if I draw the graph, it will go like this. And if I just draw a straight line there, if I draw a straight line there, it will be like this. Okay, understand? The red line shows the tangent. This is the tangent. Clear? Now what happened? This part is y naught. Here this will be y naught. Okay, and the part remaining here in this part, this part, this one, this will be k. Okay, this will be k. Understand? And here this is h. Now what I can write for x1? I can write for x1 as x1 is equals to x naught plus h. And what I can write for the y naught? What I can write for the y1? What I can write for the y1? y1 is equals to y naught plus k. What I can write? Y naught plus k. Because this part where the red line, which is the tangent, is cutting the blue line, this point is the x naught y naught. Sorry, x1 y naught. But actual what? Actual one is this one. This is actual. It should be like this at this point. But as I have told you earlier, that this gives the approximate value. Therefore, this is the difference. The difference is this one. This upper part is the difference. Okay? The difference between the actual and the approximate value. Now, the one thing is there. I can write it the slope as at x naught y naught as d by dx of y x naught y naught, which is equals to f x naught y naught. Furthermore, if I go with this part, this triangular part, this part which I want to say, this is the part. Okay, this is k, and this one is h. Here there will be the angle theta. Okay, if I go with this and if I have to find out the slope will be tan theta is equals to perpendicular over base k over h. Now here I can also write the slope at x naught y naught as tan theta. Now here it will give me k over h is equals to f x naught y naught. Now here the k will be equals to h f x naught y naught. This is the value of k. This is the difference. What it means that the value of y1 is from here, this point, to here, this up till the red point, where the blue and reds are intersecting. Okay? This is the value of y1. Clear? Everything fine? Now what is k? I can write it as y naught plus h f x naught y naught. Okay, and if I have to go for x to y2, then understand one thing. I'm not having the another marker with me of another color. No, yeah, I am having it with me. This is the green color marker. Understand? If I go with the tangent from here, then it will be here, and it will be here. It will make a huge difference between the accurate value and the approximate value. The accurate value is here. This point is x to y2. Okay, and the approximate is this point. So it will make a huge difference between the approximate value and the actual value. To overcome all these things, what we should do is we have to make a tangent at every point. For instance, here at the point x1, y1, point. Here, if I draw another graph here, if I go like this, and here this is the point x0, y0, and here this is the point, and this is the approximate point. X1, y1. I have to make a tangent here at x1, y1. Now here this line will cut x2 here. Okay. Now this difference, which is here much more than this one, I have to go with this method. Okay. What it means? It means that for every value I have to take the preceding value. Here in this case, if I have to go with x to y2, I will have to say that I will be having x1 plus h. Clear? This is x2, this is x1, and here this is h. But in case of y2, I have to go with y2 is equals to y1. This is the y1. This is y1 plus h times f x1 y1. I have to take the tangent at the point x1 y1. Mind it. Otherwise, if you go with the only x0, y0 for all the cases, then the difference between the actual value and the accurate value and the approximate value will be much more. So to avoid all these things, we have to take the value from the preceding point. Okay, fine. Now here I can go with further more things. If I have to find out the value for xn, now here this is xn. Okay, for xn I will be having xn minus 1 plus h, and for yn I will be having yn minus 1 plus h and f and xn minus 1 comma y minus 1. This is the required solution of Euler method, and this is the complete geometrical interpretation of Euler method. Now, what we will do? We will do a question on this Euler method. Just wait. Now let's student do a numerical problem with the help of Euler's method. We are going with the first order differential equation. Let it be dy dx of y is equals to x plus y. Furthermore, we are having that y0 is equals to 1, and thirdly we are having n is equals to 5, and we have to find the value for x is equals to 0.1, and step size is we have to find out. These are the given conditions for us for the first order differential equations. Now in this first order differential equation, we are having x naught 0, y naught 1, and for this x is equals to 0.1, we have to find out the value of y, and we are having 5 steps here. So first thing is that we have to find out the value for what we call as h, and h is equals to b minus a over n. And how much is b here? B is the last point at which we have to find out the value of y, and here this is 0.1, and the initial value of x is 0 over 5. Now it will give me 0.1 over 5, which is somewhat 0.02. Okay. Now here the step size is h is 0 point. Clear? This first thing is clear to you. You are having h, you are having what we call as y0, y1, everything you are having. Now let's make some here. This is xn, this is n, this is yn. Okay. Now here you can put it here like this. This is 0, and another point is 1, 2, 3, 4, and this is 5. And how much will be the xn? First case, in first case x naught is how much? X naught is here is 0. So x naught is here is 0. Then you have to add h, which is 0.02, because we know xn is equals to xn minus 1, the first preceding term, plus h. Now here this is 0, adding 0.02 to x to 0, we will be having 0.02, then again 0.04, again 0.06, 0.08, and lastly we will be having 0.10. These are the value for x. Now we have to go with yn. For yn means we have to find out the value of y naught, and here it is x naught is 0, and here y naught is 1. This is the first term. Okay. Now here y1 is 1. Up till here everything is clear to you. Okay. Fine. Now just start with another value. We have to find out the value of y1. y1 is equals to y0 plus this is what h, and and this is f x naught y naught. Okay, f x naught y naught, and f x naught y naught is this one, f x y is equals to this. Okay, x plus y. Clear? Now here if I put x naught y naught, now here if I put y naught, it will be 1 plus how much is h? 0.02 multiply by f x naught y naught. X naught is it is f x y. It will give you f x naught y naught is equals to x naught plus y naught. It means x naught is 0 plus y naught is 1. You will be having 1 here. You will be having 1 here. Now here this is 1 plus 0.02. That means that the value of y1 is 1.02. Okay. Now the value of y1 is 1.0. Clear? Fine. In this way you have to go with the other points. Just wait. This is like this. I have to solve it. May remove all these things from here. Okay. I'm just doing it out. This is, and here you have to use your GDC. Okay. Try to use it in a better way. Now I have to go with y1. y1 is already done. Now here this is y2. y2 is equals to how much? y2 is equals to y1 plus h f x1 comma y1. It will give you how much is the value of y1 here? y1 is 1.02 plus how much is h? h is 0.02. How much is f? f is equals to fxy. Now here fx1 y1 is equals to x1 plus y1. What it means? x1 is equals to how much? x1 is equals to 0.02 and y1 is equals to how much? 1.02. And if I add both of them, it will be equals to 1.04. Now here this is equals to 1.04. Now the thing is you have to do all of the calculation here. Now it is 1.02 plus, if you multiply them, this is 24 times 8, 0, 2. And you have to put 0.0 is again here because you are having 4 points after the 4 numbers after the point. Now it will be equals to 1.0408. This is the value for y2, 1.0408. 0.0408. Okay, now let's go for the third one. Now third one we have to go for it. Now students, we have to find out the value for y3. Okay, just wait, we have to find out the value of y3, and I have to erase out something which is not required for me now. This thing I have to erase out. Okay, now for the value of y3 I have to write down the formula, and the equation will come to be like this: y3 is equals to y2 plus h f x2 and y2. Now here y2 is how much? y2 is equals to 1.0408 plus how much is h? This is 0.02, and f x3 plus y3 will give you how much? f x3 y3, which is equals to x3 plus y3 will give you how much? This is x3 and sorry, this is x2 plus y2. Okay, this is x2 y2 will give you how much? x2 y2. x2 is how much? 0.04 plus y2 is how much? 1.0408. It will give you 1.0808. Okay, I have to multiply 1.0808. Okay, just wait, I have to use the GDC here. Just wait. Now here what you have to do is, you have to write down the value for this. This is 1.0408 plus 0.02 times 1.0808, and it will give you, what? It will give you 1.062416. Okay, this is the value for this. This is 1.062416. This is 1.062416. This is the value for y3. Okay, now for y4, I have to go with the for y4. In the case of y4, things will go like this. You are having y4 is equals to y3 plus h f x3 and y3. Okay, let's use another marker here. Here this is y4. y3 is how much? y3 is 1.062416 plus how much is h? h is equals to 0.02, and what is the value of f x3 plus y3? Now here the value of x3 plus y3 is, x3 is how much? 0.06 plus 1.062416, and if you add them, you will be having 2416, 6, 6, 12, 1, and this is 1.12. This is 1.122416. Okay, now just use the GDC to solve this. You will be having like here in this case, this is 1.062416 plus 0.02 times this is 1.12 2416. Okay, now the solution will be here is 1.0848. Just wait, I'm writing it down. I'm writing directly to the place here. This is the value of 1.08486 and 432. This is the value for what we call as y4. Okay, this is the value for y4. Okay, now I think this is up till here, this thing is clear to you. Now we have to go to find out the value for y5. Okay, y5. Now the value for y5 is, this is the formula, and I can write it here as this is the y5 is equals to y4 plus h4 and y4. Now value of y4 is equals to 1.08486432. There is no need to take such a lengthy number. You can go it with 1.0848, but I am having GDC with me, all things becomes easy for this thing. Okay, calculation becomes easy. Now 0.02 is here, and then you have to add this x4 plus 4 y4, and on adding this x4 plus y4 you will be having 1.16486432. Okay, now I am doing it with the help of GDC. Now GDC will do the things much easier for me. Okay, now here in this particular case I am having like this is 7 point. I am just erasing out all the things which are here, just for F1 for delete all. Now I am here to solve this and do this multiplication. This is we can do with this thing. This is called the GDC, and you know how to use it very well. Okay, this is 1 point. Oh, sorry, this is 1 not 0. This 1.0848 6432 plus 0.02 times, and this is 1.16486 and 32. Okay, this is the whole answer, and the answer here is 1.108 and 161584. This is the required answer for Y5. Okay, 1.108161584. This is the required value, and this is your required answer also. Okay, this is the required value as well as this is the required answer. Okay, now the first thing we got from the Euler's method is this is the method with which we can solve the first order differential equations, and not only the first order, we can go with the first order, second order, third and fourth order also, but here we are not going with it. We are just going with the first order differential equation with the help of Euler's method, and I have explained you about the geometrical interpretation as well as we have done a question on the first order differential equation and how to solve it with the help of Euler's method. Hope all this will be very much beneficial to you. So just wait.